Hello everyone, I am PANDIRI Krishna from Chanakya University. Today I am going to present my project titled Machine Learning Based Heart Disease Prediction, where I compare multiple machine learning algorithms to identify the most effective model for early detection. This process focuses on how artificial intelligence can assist in saving lives through faster and more accurate decisions. In my present outline, in this, I will briefly walk through the problem, the dataset, methods used, and finally the results and insights obtained from the study. In my introduction and motivation, uh, cardiovascular disease is the regarding cause of death worldwide, accounting for nearly 31% of all deaths. One major issue is the early detection is often difficult due to high costs and lacks of medical experts, especially in rural areas. Machine learning provides a powerful solution by, by enabling automated, fast, and cost effective prediction systems. So, the main goal is the project is compare different performs best heart disease and prediction. In my dataset description, in this study, I used 5,000 patient records with 13 clinical features. These features include important medical parameters such as age, cholesterol, gender, chest pain, resting blood pressure, serum cholesterol, fasting blood sugar, remaining. So many features are there. The dataset is clean with no missing values, which improves more reliability. The target variable indicates whether a patient is diagnosed with a heart disease or not. My exploratory data analysis, my paid part before I applying learning models perform exploratory data analysis to understand patterns in the data. From the analysis, I observed that patients with lower maximum heart rate are more likely to have a heart disease. Certain types of chest pain strongly indicate disease presence. High visual count directly associated with high risk. These insights helps to understand how futures influences in the prediction, future distribution and class balance. Class balance. I also analyze in how much future is distributed across patterns. This data shows the slightly higher number of positive cases around 64.5 and insightly both male and female patient shows the almost equal distribution affects both genders similarly in this data set. In my correlation analysis heat map, I to understand future importance, I used correlation heat map. This shows how strongly each future is related to the target variable and features like test type, visual count, and exercise included. So strong positive correlation will maximum heart rate shows negative correlation. This helps us to identify the which future are most useful for prediction. In my methodology, I used five classification algorithms, each model trained on 80% data, evaluated on 20% allowed the test set. I used one is logistic regression, and another one is artificial neural network, and another one k nearest neighbors, and another one decision tree, and last one is Gaussian navigations. The dataset was split into 80% of training and 20% of testing. Before I training, I applied data pre-processing techniques such as scaling to improve model performance. Each model was evaluated using accuracy, precision, and recall and F1 score. In my experiment results, the results shows the decision tree model and achieved 100% accuracy, making the best performing model in the study. The artificial neural network achieved 98.5%, showing strong performance even with a simple architecture. Logistic regression and KNN also performed well around 94%. Navi biases shows lower accuracy due to its assumption of future independence, which is not suitable for this dataset. In my confusion matrix gender analysis, the confusion matrix of the decision tree, the tree shows zero error. It meaning it correctly classified all test cases. This indicates excellent model performance, but it also suggests as a possibility of overfitting, which is needed further validation. In my decision and clinical insights from these results, we can conclude that decision tree is powerful but requires unit aware overfitting. Neural network can achieve high accuracy even with a simple structures, and logistic regression is useful for interpretability in clinical applications. Navy biases less suitable when future are highly operated. These insights are more important when selecting model for real world healthcare systems. I conclude that the decision tree model achieved the highest accuracy. All models perform above 80%, making them useful for prediction. Key features like chest pain, heart rate, and whistle and count play and major role. In my future work, we can improve the system by using advanced models like random forest, XGBoost, and by validating with near hospital data. And thank you for watching for this presentation. For the presentation, I would found this video useful. Like, share, and subscribe to my channel. Feel free to ask any questions in comment section.